variables and add the actors to the show list each frame, something like that. So what we're gonna do is we have to have like a post creation tick where we add all these things to the, we're gonna clear that array of actors and then we're gonna add them all back or something like that. Dashkin VR, it's just you running into a wall really fast. It's just wham. Camera shit, yeah, it's just we'll just bail on this project and it's gonna be Bitey Rides Roller Coasters VR. I'm just gonna sell out immediately. It's all gonna be Disney roller coasters too. Just so Adam can feel really awful about his life. I don't see any other crazy flags in here. So if we go to scene capture component.h, engine show flags. See this like to do here and then like crap not working is just like, yeah, I don't think this crap works at all. Roller coaster. Alright, so we're just gonna call show only actors. And what we're gonna do here is we're gonna build our T array of a actor. We're gonna do like actors shown. And we need to call this in the update tick. So we're gonna call like recreate shown actors for render targets. And we're just writing some really awful code to start with here because we're still just figuring out exactly what we need to do. That's what we're doing. So we're trying to make an array of things that we should actually show. So we're going to pass in, we're basically going to grab, yeah, we need the scene captures first. And I need to get all the actors in the entire world and then iterate over them and like grab all of them that have, well, why don't we just add like a tag to a mountain or something like that, and let's just call like should render this is just going to be capture component 2D, and it's going to be shown actors, show only actors dot reset, and then we're going to show only actors dot add. I think it's maybe append or something like that. So we're just gonna log it out, info log, adding %d actors to be rendered in the scene. Actors shown.num. called to recreate our actor render list. So to start with, this will render everything because I'm assuming like I don't see any Boolean flag here that's like that's actually, yeah, update the show flags. There's a lot of excuses in the comments here. Like, it's like, update the show flags. Ideally, you'd be able to do something else, but because of some random reason, this isn't my fault. It's just, whenever you see that, you're just like, okay, so what the hell's going on here? Because obviously, whoever wrote this was just upset at somebody else. Which is why the other day somebody's like, well, if you're working inside of Unreal, you're working with high quality code. I'm just like, you're at least working with tested code. Quality is relative to lots of things. Alright, so what we want to do is we want to like grab one of these. Let's grab the mountain in the background here. And on its actor, we'll just add a tag to it. And what was the name of the tag? Should render. So the only thing that we should see inside of this viewport is this big mountain in the background. Because it's the only actor that's got should render on it. Let's take a look. Actors shown, there's only one, it's the hill in the background. So we're going to do that, and we're adding one actor to be shown. So when we go over here, as you can see, we only have our one actor rendering. And everything else is black, as you would expect. And we've got our cone there. So, what are we going to do about all this? Where is the cone? The cone is a little bit off right here. So the question would be, do we want to do anything with the 3D objects that are inside of this plane? So if we basically move this camera up front here, you know, this cone shouldn't be rendered, is the idea. So let's think about this for a minute. So if we've got a perspective camera, we basically want to set our near clip plane for, I think, our orthographic camera, and we want to set the near clip plane to be the plane basically of this track. So let's get that rolling here. Let's see if I can change that. So it's this M camera set ortho width. So camera is a view camera component, so we should be able to go to camera component.h, and let's see if there's a near clip. Yeah, so set ortho and near clip plane, and we're gonna want to set that to something else here. So we've got this G camera follow vector, and we want to set it to, it looks like the X component of that. So why don't we just set that? So basically what we want to do is the X of the position of our current thing. So current position dot X. So it's going to be M camera set ortho near clip plane, and we'll set it to the current position.x, and we're going to subtract a tiny float from it. So we're going to bring the near clip plane just shy of our current position x. And we'll see if this does anything good for us. We may need to bring it back farther. But let's just see if that cone at least disappears. And I don't like it that it's a tier A for actors that are shown or not. It'd be much nicer if it was a set, because then we'd have much easier add and remove from the tier A. Which is actually something I might be able to go change, so I can go change that to a T set. Hopefully they're just doing iterations on it as opposed to like some indexing bullshit, and I can just chunk in there and fix all their unoptimal bullshit. So the cone did not work. Why not? And I guess we probably can't set this to 1,000. We need to set it to the absolute value of this. Because probably setting it to minus 1,000 for the near clip plane isn't going to do. Yeah, it's not going to do anything. It's going to be like, is 500 less than negative 1,000? And it's going to be like, no, 500 is a positive number. And I'm expecting that the terrain might disappear on this one for our main camera. And we're also going to want to set our far clip plane. So it's going to be basically, we have this track, which is 2D only, and we can just basically cut it real close. A little slice of all the things. Then we don't have to worry about much. Yeah, so as we can see, we're only rendering stuff that is. Yeah, we can still stand on those invisible platforms. So let's take a look at what do we want here. So this guy is at negative 300, this guy is at 55, so 0 is somewhere in the middle. And the cone disappeared. So basically what we want to do is we want to create a little, I think just a little strip here where we're just doing orthographic. And we kind of want to define exactly where that's going to be, right? So we want enough space so there's not going to be any Z fighting, and we don't want that much space because then we might have issues. So if we set the near clip and far clip to be, it looks like kind of negative 300 to maybe 100. We just set this to 100. Where does it go? So that's 100 right there. Yeah, so we should do like 150 to negative 300, something like that might be fine. So this track right here gives us, I think, plenty of space. So I'm gonna go ahead and throw that off into constant territory. And the other thing is, this thing now needs to actually come up. It needs to be like right, you know, back here at like the 150. Yeah, why don't we just do 200? You know, 200 right here. To maybe we could do constants. We could do like maybe 400 to 400, something like that. Positive 400 and negative 400 is probably a lot easier to remember. It gives us enough little layers to mess with, I think. So let's do that. Alright, so static, const, float, G camera, max x is 400, and static const. Const float G camera min x is going to be 400, negative 400. All the things. So how's everybody's day going so far? Hopefully it's going well. Looks like at least Perforce is doing well. It hasn't been dropping connections. Oh no, our source indexing failed. Our Perforce IP address is not found in sourceserve.ini. Oh no. Well, let's go look for it then. Well, I'm confused as to why source... I can fix source indexing crap later. We did fix the build at least for the other things. I'd like to spare everybody the pain of dealing with Perforce and version control. But basically the source serve ini file and all that lets us, when we get a crash, it automatically pulls up all the source files from that specific build and lets us just fix things. And that's not super important at the moment, but it's going to be absolutely critical when we have crashes from customers or from other people testing the game. So what we need to do here is we need to set our ortho near clip plane to, basically what we do is current position .x Our x is always going to be negative. So we're actually going to be taking the absolute value of the difference between those two, I think. Except that's not correct. We need to take the absolute values of both and then subtract them. So it's gonna be like 1,000 and then 400. That doesn't make any sense. Really, we're just gonna do the it should be 600. So we do minus a negative number, and we're gonna get bigger. So near clip is gonna be fmath absolute value of this, and far clip. Far clip is going to be the max x. So this is going to be minus 400, so we'll just do near clip and far clip. You have the far clip distance in here. Yeah, we're just going to turn that off. So we're going to set it to far clip plus a tiny float. So we'll see just a very small bit pass, and just 2. Alright, let's see how it goes. Oh man, we love compiling. So what this should do is, this should set it so we should be able to see everything in the scene there nicely. And then we're going to move the cone outside of it. And then basically what we can do is, we can just have a temporary hack in here for us to iterate over all the actors and add them to a list or whatever. And what we really want is we want these actors, all of them, to automatically figure it out. So like if they move in the scene, they'll check themselves and be like, did I move within the near clip and far clip of the camera? And if so, then I can toggle my renderability for the 3D camera. So yeah, everything's here and the cone is not. So, good. And this guy needs to be at the very back of the far clip plane. So let's go ahead and set it to that location. Can we get the camera component? It looks, is this public? Probably, so should be able to grab it. So basically we want current position, and we want basically the ortho far clip plane, so it's like in camera, ortho far clip plane minus the tiny float. It's going to be the X location of that. So that should set our scene quad properly to just behind. So now we should see our stuff in the background. Our mountain should be there. Our mountain, and then we can add the cone. Alright, so our mountain is there. Looks like it's working. And we're just going to throw a nice little hack in here for basically get all actors is going to be something. So we have like world.h, get all actors, or get actors, get actor. View world active group actors? No. See, get all actors. Get all actors. Oh. So we want to get all the primitive components in the world is another thing that we'd want. So let's see, UWorld, Unreal. Get component, there's like components by class. What the hell are all these functions? They're in here. We just need to go to our entity utils. Or our game instance. Game instance as it's going to be in the game mode. Get all actors of class, get all actors, get player controller. It's gameplay statics is the thing. So gameplay statics is where we need to go. Oh, give me a fucking break. Documentation is a real pain in the ass. Get actor array bounds, get all actors of class, get all actors with interface. Get player camera, get player, remove player. Get all component. There's just get all actors of class. Well, let's see how they're getting them. Get from world for all. They're just iterating over the world and getting all the actors, so it's literally just this. So to get all the actors, so basically if actor get position, is there, or just get transform, get translation, x. Just do float x equals this. If x is less than max x, or x is greater than max x, then we add them. Otherwise, we don't add them to the actors shown. So this should hack it in there. So we should see everything in the whole scene, no problem. And when we hit play, it looks like everything is there, except I don't see the cone, dude. The cone's not there. Where'd the cone go? Maybe the cone is too close in some respects. Like maybe we need to move the camera back from the scene quite a bit to see the cone. Oh, we'll see. because that's pretty close to the camera. We might need to bring it back a little bit farther. So let's actually move this guy to -2000. Adding 18 actors to be rendered to the scene. Alright, well, can we get the name of the actors that are getting rendered? That's probably what we'd want. So if the x is less than min x, or the x is greater than max x, add them. So these guys should be getting added. Let's see, actor, let's just lowercase that. Let's see. Is it U objects that have F names? Is there literally just like an actor to string method? Well, there's just a get name. Alright, so. So we should at least see if we're adding the camera, the cone to be rendered or not, and then we can walk through it and debug it a little bit more. So what? Adding brush, cone 2. So cone 2 is there. Hold on a minute. Yeah, so it's there, but it's being drawn behind everything in the scene instead of in front of it. And you can see it looks pretty awful. It's basically just too close. That's what it looks like. So we need to bring this guy back to like minus 5,000 or something. Is what it looks like. What? Alright, we'll fix that crash. And we'll also change this camera distance to something a little farther back. Looks like we're gonna have to figure out exactly where this camera should be to make it look proper. And we could probably do a little bit of math to figure out exactly where it should be. Because basically what we want is the view frustum to be exactly the size of kind of at the far plane for the object, the max. Gosh, well, we want actually 0, 0, I think, to be where we want the rectangle to be exactly the same size. So we need to pull the camera back based on the field of view to where the width and height match the width and height of the orthographic, you know, the size of the screen at that level. So like right here, you can see it's pretty far in the background now, and we would expect it to not be like that. Yeah, you can tell. It looks like it should be behind the object, when it shouldn't be. It should be in front of the object. And it should look like it should be in front of the object. So we're too far back. So we should do some math. And what math should we actually do? Okay, so I'm also getting pretty hungry, so I think I'm gonna grab a snack real quick. So I'm gonna be right back. Where is my pen? So what we need to do is basically what's going on is we've got our 3D camera and it needs to be basically project onto this thing that we're viewing in orthographic land. And we need for an object that is showing up at a certain size here in the foreground, we need to have that, if it's going to be a 3D object rendered by our 3D camera, it needs to show up at full height. So when this thing gets rendered, if something's right here, it needs to be at the exact top of this thing, and if it's at the bottom, it needs to be right at the bottom. So this plane is what's really important. And what about height? Like this 3D camera also needs to. Do we need to worry too much about height? I think it's more about we need this to be at the appropriate distance away from the camera, and that should be based on the aspect ratio. Well, we need to know the distance right here. So in order to do that, we need to have the height of the view frustum at the intersection between a specific plane, and it seems like that's probably the near clip plane of the camera. So like -400 is this thing. So the actual like render target sprite is back here at +400, and this is, I think, -400, and this is 0. So what exactly is that value going to be? We need the intersection with -400 with our camera. So we know that the distance here is going to be such, and we want this height here needs, we do know the height of this. The height of this is 1/2. The height is 0.5 times screen height. And we know this location is, you know, the position of the camera. So if we just take the position of the camera, like a squared plus b squared equals c squared, right? Because we got this vector right here, at least, and we know this vector. Do we know? We don't know this vector yet. We do know positions though, so the top position is going to be the camera position at the top position is going to be camera, it's going to be -400. The Y is going to be camera Y, and the Z is going to be camera Z. Well, it's going to be camera Y if Y is up. Y is not up. It's going to be camera Z plus 0.5 times screen height. The bottom position is going to be such. And then it's the relationship between the was it the field of view? Because it's basically going to be like something, the field of view times distance is going to be like screen height. Or something like that, right? Yeah, so field of view in degrees and perspective mode. So let's see, what is our field of view for our basic camera? The field of view is 90 degrees. So basically, we know the cosine of the sine of field of view Yeah, it's going to be cosine of field of view times the distance is going to be, well, no, it's cosine times the distance of the camera position. Cosine of field of view times the vector. It's going to be top minus camera pos is going to be equal to the distance. So the sine of field of view well, we know this is 45 degrees. So the y is going to be the sine of 45 degrees times the height times the height. I mean, this is just basic math. I just haven't done this shit in forever. This is definitely like a high school math problem. We need more high schoolers in this chat to tell me how to do math.